Combining theorems 4.23 and 4.24, we get the following theorem! An n by n matrix is diagonalizable if and only if the sum of the geometric multiplicities of its eigenvalues is n. So therefore, in order to understand diagonalizability better, it's important to understand geometric multiplicities better. And to do that, we introduce the following lemma. Bet you thought I was going to say theorem, but I didn't. I said lemma. Lemma. Which is basically a mini theorem, but I said lemma. Ha. Ha ha ha. Ha. If lemma. I bet you thought I was going to say theorem, but I didn't. I said lemma, which is basically a mini theorem, but I said lemma. Ha. Ha ha ha. Ha. If lambda is an eigenvalue of an n by n matrix A, then its geometric multiplicity is at most its algebraic multiplicity. So now let's talk about a main consequence of this lemma. So here, let A be an n by n matrix with distinct eigenvalues, which I'm calling lambda 1 through lambda k, algebraic multiplicities a1 through ak respectively, and geometric multiplicities g1 through gk respectively. So in other words, lambda 1 is an eigenvalue, a1 is its algebraic multiplicity, and g1 is its geometric multiplicity, and so on. By lemma 4.26, we know that g sub I is at most a sub I for every I. We also know by the definition of algebraic multiplicity and the fundamental theorem of algebra that a1 plus dot 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 plus ak is exactly n. Therefore, g1 plus dot 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 plus gk is at most a1 plus dot 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 plus ak, which is n. So, putting these things together, along with the theorem above there, we get that A is diagonalizable if and only if g1 plus dot 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 plus gk is n, and this is by the theorem. Which is true if and only if okay, well, in order for this entire sum to be equal to n, the only way that can happen is if each one of these gi's, g1 through g2 through gk, is as big as possible. Or in other words, if and only if g1 is a1, g2 is a2, dot dot dot, and gk is ak. And so we have proved the following theorem! The diagonalization theorem. Let A be n by n with distinct eigenvalues lambda 1 through lambda k. Let g1 through gk be their geometric multiplicities, and a1 through ak their algebraic multiplicities. The following are equivalent. A is diagonalizable, g1 plus dot 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 plus gk is n, and gi is ai for all I.